So this one row level lock on a database table brought down the entire website. LLMs are just a rubber duck that talks back.
And if you make technical decisions just for the sake of technicality itself, like you're not doing a good job in your business.
It's one of the few jobs where if you stopped paying us, many of us would still do this for free in our spare time. So when they ran benchmarks, they could hear the log.
This is an interview with Andrew Harmel-Law, a principal architect at ThoughtWorks and author of Facilitating Software Architecture book. We discuss the InfoQ State of Architecture 2025 report, architecture advice process, and indeed how AI flips the architecture game. Enjoy the conversation. All right. Have you read this report?
I have, not properly. I read it because various people kept asking me questions about it. This is one of the because I'm a consultant in my job. Things like this, obviously, or maybe not obviously, but the ThoughtWorks Tech Radar stuff will come out, and then suddenly I'll be asked questions about things that I'm not entirely aware of. So I haven't read it properly, but I've read it hopefully enough to know what you're talking about. And so, it's interesting to me because they're quite good at being on top of what people are thinking about and asking about. So they're usually. Maybe even they set the agenda sometimes, which is good.
Well, the report has a lot of things on its plate. It's like RAG, AI agentic workflows, and then observability and green technology at the same time.
Yeah.
So I spent 4 years working for a service company like EPAM. And in such companies like EPAM or Accenture, there will be a solution architect who will be making decisions, right? So picking up the technology stack, maybe interviewing the team, making a call about the database technology, and so on.
Yep.
However, in your book, Facilitating Software Architecture, you're advocating for this architecture advice process.
Yeah, exactly.
How this process should flip the architecture game and improve the quality of architecture decisions?
So it's a really good question. So the way it flips it for people who haven't read the book, I kind of controversially state in the book that, so the premise is that architecture is moving faster and our architectures are kind of getting more decentralized, they evolve, they change all the time, all of this kind of stuff. So my premise in the book is that you need more architecture, not less. But if you have a traditional approach where you have a fixed number of kind of people with architect in the job title, like systems architects or like enterprise architects or whatever. There's always a different name. And one of the things I've learned is I even had to put it in the foreword of the book to make it clear who I was talking about because people weren't sure if I meant them or not. Fundamentally, I meant people who are kind of close to or 1 or 2 degrees moved away from software. The thing I proposed in the book was this thing, like I said, called the architecture advice process. And the idea there is, as it says in the process, anyone can make any architectural decision, anyone, as long as, and this is the kind of social contract element, you can make the decision as long as you seek advice from everyone who will be affected by the decision and everyone with expertise. And so that kind of means that more architecture can happen in more places. Fundamentally, it means that you get more architecture by people who are closer to the code. People, however, misinterpret it because they mean that they think that's the only place architecture comes from. So what it does is, and this is the reason the book is 460 pages, that simple kind of leverage point, fundamental change in the socio-technical system of doing software architecture, means that architecture can come from more places, but people who are responsible for systems architecture or the higher level architecture are still doing that kind of thing. They're just doing it more in partnership with the individual teams who might be making smaller level decisions. And the other part, or another part of the 460 pages is technically it's anarchy. Like if you look at the dictionary definition of anarchy, right? So it's like a decentralized control and, but the whole point is you're still supposed to be headed in this general direction. It's not chaos. Chaos would be bad. So the idea is that people who are doing the architecture that's maybe broader scope or longer term or broader impact, they then step back and they do more of the frame setting. So they'll spend more time being explicit about non-functional requirements. They'll invest more in capturing things like architectural principles. They'll be doing more things like, because I'm ThoughtWorks, so like for example, doing something like capturing an architecture radar, but fundamentally having something which is a situational awareness so that all teams can be aware of what other teams are doing for like the technologies they've picked or the approaches and the patterns that they're using. The idea being not everyone has to follow the same direction, but the one kind of piece that I say that you should do to make this work, if you don't, it would be chaos. You need to do decisions out in the open and write them down. So you write ADRs, like the classic architectural decision records. And when you seek the advice, and get it written down on the ADR. So therefore, you could be the systems architect, right? And you're looking over everything and trying to make this whole system work. I could be in a team and I want to do something different, but I would still have to seek your advice and input. You would still write your advice, and there's a story of this in the book. You might say something different. I could disagree with you. The approach would empower me to disagree with you, but I will be the person who's responsible for taking that decision which goes contrary to your proposal, and I'm now the accountable person for that decision. As opposed to in the old days, right, you had less architects and we were all accountable, but we just hoped it got into code. Now I might be closer to the code, but now it's my fault, right? We can see you in the comments saying, Andrew, this is a terrible idea. This is completely contrary to all of our decisions and everything. And so what that does is it has people are empowered or enabled to do things, but they have the accountability. And so one interesting thing that I've noticed is if you read things like the Open Group, the TOGAF people, if you read their approach to architecture, their new agile approach to architecture, says that decentralized architecture designing is good as long as you move accountability and responsibility to the same place. So the people who decide are also accountable for it. And that kind of balances stuff out. If you have someone who's determined to be like a chaos agent, then that might still happen. But then I would argue if you had that person working in your architecture anyway, working in your software, then they might be doing all this kind of stuff anyway. So before I shut up, the key point about this is it's kind of based on trust. I trust you to decide and you trust me to decide, and we all trust that we all work together. The place it doesn't work, because people ask where it works and where it doesn't work, it doesn't work in places with low trust. If there's low trust and there's never an environment where trust will build up, it will hard fail. It'll go badly wrong. My argument in the book is that more places are more trusting than we think, because mostly we like our colleagues and we want to build software that works and we want to be able to evolve our systems, but it doesn't work everywhere. So yeah, I'm not naive enough to think that you can just magically make all human beings perfect and then they'll all do the right thing, because they don't do the right thing. They just come up with different opinions.
But what does accountability stand for in the context of making architecture decisions? Like let's say we have some platform team and they tell us that you should do all the inter-service communication with gRPC. We have tooling for that and so on and so on. And then one day I say, okay, you trust me with the decisions to myself.
Yep.
And I decided that we need to introduce REST for some new service.
Yes.
And then it means that the platform team actually will have to provide some tooling. Or if something bad happens because we didn't implement the rate limit in our circuit breakers for this new REST stuff, then what does this accountability mean actually? Will I need to how I will need to handle the consequences of me forgetting implementing this essential stuff despite the platform advising against it?
Yeah, it's a great question. So in that thing, number one, the platform team wouldn't do it. It would be me taking the decision to separately do those things. So I would benefit from, and this is in one of my chapters, the reasons, platform teams are great, especially if they're providing things that people want to use, as many platform team product managers talk about all the time, and platform product managers. So like at Netflix, if I want to go the other direction, I can go that direction, but I'm responsible for all of it. I have to pick the technology, I have to do all the implementation, I have to, just like you said, implement all the rate limiting, implement all of the bulk, blast heading and all of that kind of stuff. That's that can lead to problems, because some people just haven't built software at a large enough scale, which is this is the thinking that people who become architects are good at, right? They're like, I remember 3 years ago when we didn't do circuit breaking, and one row lock on a database table, because this did happen in my career, a database table locked, which then exhausted the thread pool in a connection pool, which then flooded the resources on the VM which was working, which then flooded all of the other things which were running on the same VM. So this one row level lock on a database table brought down the entire website. and I'm not going to say which customer it's for, but it was big. People just don't, like, you learn that from experience, right? You don't learn that on purpose. This is why having things like clear NFRs is key, because typically, so I mean non-functional requirements, right? Typically, if you're a platform team, one of the sales pitches is not only it's a nice, cool thing to use and it works really well and it's easy. One of the sales pitches is we know we need to meet these non-functional requirements. We know that we have this capability that's able to support our basic traffic, our availability goals, our resiliency goals. If you don't want to use our stuff, here are all of the things we support. So if you don't support them, then you'll probably be in trouble. Again, someone could recklessly go off and do that, but I've never seen that because people are like, oh, okay, so maybe I might in that case lodge a feature request with the platform team and collaborate with you to build this thing. And then you get to what you really want with platform teams, which is you want to have, like in team topologies, you want the teams to be enlightened consumers. You want the teams to be sending you, and this is the bit that I like, one of the bits I like writing the most in the book. You want not only like a top-down, we've made this easy for you, you want the bottom-up sensing, which is like, we know that's easy, but this is where we think our architecture or something is going. So you've got this kind of back pressure. And what was really cool was I reread Christopher Alexander's pattern language. So the pattern language is very top-down hierarchical. It starts with the big patterns, then it works to smaller patterns. At the end of the book, he talks about the process of repair, which is there's like a weaker but more diffuse signal coming from human beings living in the environments that they've created, right? The rooms they live in the buildings that they live in, that are in the neighborhoods they live in.
Mm-hmm.
The weaker force is what he calls the process of repair. So that's what kind of slowly evolves, etc., etc. And if you can factor in both of those, somehow you let this kind of culturally, you use this approach that anyone is free to change bits, but they probably change bits that are small or big or whatever. Then you get this kind of cycle, feedback cycle, and kind of dialogue between people who are using the tools to build stuff and run their systems, and the people who are trying to provide the tools, like more town planners or like platform teams might be like utilities providers or something. They're like providing you with power and electricity and all this kind of stuff. Then you get this feedback loop. When I've seen this work well, and there's a few case studies in the book, it's super cool. Like suddenly platform teams are like, we get really good feedback. We get more enlightened usage of all of our stuff. And then you're not just getting something which is just a carbon copy of what Netflix did, because you read their blog and you built what they said, right? You like Google, so you copied what Google did. You evolve this kind of thing which is a better fit for your teams, with your skills, in your culture, in your market, with your product. And then you get all this stuff going. The problem with the older approaches is it's very hard for things to come back up because of the architecture. Typically architecture comes down. If you let this come back up, it works super good. So one thing that was nice actually was the QCon, I don't think the talk's out yet, but the last talk in the QCon track that I got to convene a few months ago, the last talk was the chief architect from the client where I first tried this, called OpenGI, because I'm allowed to mention it. Him and a lead developer, they did like a 4-year retrospective of what happened, right? What all the good stuff, some of the bad decisions, some of the good decisions, and how their culture evolved of this more diffuse kind of decision making. And it's a super interesting case study. They got there's a lot of screenshots of people commenting on the bottom of ADRs, which are very interesting to read. So I can remember some of those gigantic battles in the bottom of like ADRs where people were like commenting and stuff. So it was good.
All right. Talking about the ADRs, I have the next question.
Yeah, sure.
So, well, first of all, InfoQ report just stated that ADRs received early majority, which is kind of surprising.
Yeah.
Because I think everyone is doing this, but that's my perspective.
Yeah.
Yeah. What are the different ways that you saw companies actually using ADRs? Like how they do that, why they do that?
It's a good question. So you're right. I thought everyone was doing it, but I have had feedback at conferences where I just talked about ADRs and then someone said, we don't know what the word, or some people in the audience didn't know what an ADR was. So it's an architectural decision record for people who don't know. I thought as well, I thought Michael Nygaard was the smart person who came up with them. And then Bruce Mallon, the famous architect, read an early draft of my book and said, someone in the 1980s, I can't remember what the footnote is, but somewhere in the book someone originally came up with it, and then Michael Nygaard just made them popular. So I've seen them be records. The thing where I think, which is not bad, but I think is like missing opportunities, where they just, someone does all the work of deciding and then they document it as a record. It's not bad, but what worries me there is the thing that I've learned is that you can think by writing, and this is definitely something you learn as an architect, right? So you do the work, you do the writing, and you discover by crafting a nice context and by crafting your options, you do a lot of thinking. And by having it read by other people, you also get a lot of thinking for free, right? Because people read it and then they give you feedback. So missing out on that, I think, is a bad thing. I've also seen people go, like, ADRs are, like Michael Nygaard pointed out, are supposed to be lightweight. Sometimes you see them be gigantic and they're basically like small chunks of documentation. I don't think they don't, to me, fit nicely as, and I've spoken to Diana Montalian about this a lot, they don't substitute for a nice clean architecture, maybe not too heavyweight, but something where someone can go and say, what is our architecture? Where do our pieces fit together? You shouldn't have to read 1,000 ADRs to find out that information, but sometimes you see that, right, where people are like, oh man, I can't even tell what the current architecture is. And then, but what I have seen, and this is what I advocate for, but I did not create this idea, right? People were already doing this. Using it to think collaboratively. Other people gave me feedback, so I spoke to one of the people that gave me feedback was I think the chief scientist at Stack Overflow, or the chief engineer architect at Stack Overflow. They do a similar process. They just use RFCs, so they're not ADRs, but similar. They have a written context where everyone's invited to do things. I think the RFC kind of approach to ADRs, I think, is super powerful. And what I like most is, again, sometimes you'll just see like a sea of ADRs. What I like is, which seems to work best for me, is where they kind of self-organize, they kind of stratify into higher level, broader ADRs, lower level, more team-centric ADRs, maybe with a fuzzy edge, right? Because sometimes it's a bit hard.
So that's like a tree structure,
yeah,
right?
kind of,
So
right?
you have like systems level ADRs, then application level ADRs, then module level probably.
Yeah, exactly. And like, so people, although I'm quite famous for, people ask me what levels and I'll dodge the question because my answer is like, it depends on your architecture. It depends on the scope of your responsibility, right? If you're a small team, there's no point splitting them out to those different levels because one human being maybe roams across those levels. Other times, you will see them stratifying. Other things actually I've seen, the last 2 clients I've worked at, we did product decision records because many of the very early architecture decision records were like 1% architecture and 99% product direction. So we pointed this out, and then most of the people doing the commenting were the product managers. So then we just said, can you not just write product decision records and then strip out the architecture, and then we will have a subsequent ADR which will say, right, you've decided that the product direction is this, or even like nice ones I've seen is the MVP is this, the scope is this. Don't define the architecture of the scope, just define the scope. We'll then create a separate ADR for the scope. And then you get a nice kind of structural, way of reading the story of the architecture, which is really good. So it's definitely, they're more, if you think of them as, the last thing actually, I'm talking a lot, but the last thing that winds me up is when people, ADRs are immutable. Michael Nygaard's very kind of clear about this, and I agree. If people keep reopening ADRs, that winds me up no end. If you have a decision you've decided because it's a record, right? It's like a mutable event log. If you have another decision, even if it reopens the previous one, it works far better to like have a new decision which supersedes the old one, and then it sits on top of that previous one or sits alongside that previous one. So then you record the previous decision and the new decision, which hopefully says why you've changed your mind, like why you've moved from gRPC to REST or something.
Yeah. What is the most striking example of rewritten decision that you saw?
I've seen some really good ones. So the best one, I can't name clients. There was one where, here's a good one. So like a good one was, I was at one client and their strategic direction was we're going to use AWS, everything on AWS. Product came along and they wanted to release a feature and the feature wasn't available on AWS. So architecture said no. Technology said no. And they were like, no, but we've been to the CFO and we can make we've done some proper, they've done proper product management, they've done proper modeling, and they were like, this can make a lot of money, so you need to break your architecture. So there was like a famous ADR And then the CTO was very clear that this doesn't mean everyone can do this, but here's a good example of us breaking the architecture. They wrote a very big ADR with lots of detail from product, like these are the reasons why. And for a short period of time, they put one of these features, this one feature, into Azure because it had certain capabilities which Amazon weren't going to have. And then they time box the ADR. So they're like, we will come back to this in 6 months. So it's like, basically, we know it's architectural debt. We've taken this hit for these very valid reasons. And then in 6 months' time, we will come back and hopefully then this thing is available in AWS and then we will port it back. And it worked really well. So that was the one that kind of, it was explicitly, they knew they were going to supersede it. And I think they even, maybe they said to Amazon, maybe Amazon didn't care. But we're doing this because we can't go with you. Here is how much important it is to us. Here's all of the rest of our stuff in Amazon, but we can't do this with you, but it's worth breaking our entire architecture for. And to your earlier question, that meant they had to set up all of the ingress, all of the security controls, absolutely everything for Azure, which was not cheap, right? Like super complicated, which is why they were like, do not do this. This is just a one-off, not everybody. But it was really good. It worked really, like it was a super good, explicit CTO enabled. It went that high, but it was really smart. So
that's a very impressive example of like how business can drive like the decisions that are crazy from the technical perspective, but still viable. Yeah, that's
and
also,
then it was good because then business, because this thing, technology had to do tons of work. Which, if they'd just done it on their own, they would have been like, "Why is this taking so long? Why is it all? Why are you telling us all these problems?" Right? And they were like, they were bought into all of it. They were like, "Okay, we get it. We understand it's expensive, etc., etc." But yeah, so it worked good. I wouldn't advise this very often, but it was a good option, so.
What it serves like as a good story for like the technical implementation is actually bound to the business context, 100%. Right? And if you make technical decisions just for the sake of technicality itself, like you're not doing a good job in your business.
That's a really bad smell. So like Dan Montalian always says, or keeps saying to me anyway, architecture is always it depends. The question is, what does it depend on? That, like the writing piece, using the writing to figure out what it depends on is super important. When you get that, then you get better decisions. We were talking about better decisions before we started. Better decisions are based mostly in the context of where you are right now, which might suck, right? You don't want to. They didn't want to have to go to Azure for this one thing, but that was the reality of the world. So they did the thing based on that reality. Right?
Yeah, great example. Awesome story. Still waiting on this staff engineer bump? Stop just shipping tickets. Start designing systems your CFO can brag about. Business-oriented system design course cohort number 6 goes live on 23rd of July. 10 weeks, live sessions, and asynchronous personalized feedback. 70 plus alumni from Booking.com, Bolt, and Flow Health report a 50% average compensation increase within 6 months. 11 seats remaining. Apply now at websalvage.dev business-oriented system design course and use YouTube20 promo code to get a 20% discount. All right, let's start talking about the thing that everybody is talking about, AI. You can't jump into the office without hearing AI, LLM. AI.
Yeah, exactly.
A lot of people are doing AI-assisted coding already, right?
Mm-hmm.
There's Cloud Code, Codex, ChatGPT, Juni, Cursor, Windsurf. Every second company is buying every first company, and so on. That's crazy. But that's like almost exclusive topic is AI assistant, right? So we code, we have agents for writing features, and so on and so on.
Yep.
But what I hear less is how AI enables better architecture.
Mm-hmm.
So my question is like, did we find already some niche or space where LLMs and AI solutions can help with software architecture, or we're yet to discover that?
It's a very good question. I was terrified, so I will freely admit I did not, because I was writing a book, which is a lot of effort. I was too scared to use LLMs because I didn't want an LLM to show how easy it was to write a book. So I stopped using it. As soon as the book was done, I did some experimentation with Brigitte Böckler, who's I don't know what her title is, but she's the person at ThoughtWorks who's paid to keep track of all of this stuff because you need to have no other job because it moves so fast. So we played around with, and Birgitte's kind of wrapped it up into some things which I need to have more of a play around with. one of the cool things, and you mentioned RAG as well, like earlier, if you know what you're doing, because so architecture is hard, like I said, and knowing it depends is important. It depends on a lot on your existing code base, all of the stuff, there'll be a load of documentation or loads of old stuff on your wiki probably, or some massive documentation somewhere. Those knowledge bases are typically written down if you're lucky, but they're not in everybody's heads. Not everyone, no single human being these days can understand everything that's going on in a code base. The current environment of what systems and services are available from all the cloud providers, plus all of the, everything else. There's too many things to know. So setting up RAGs, and we did experiments with this with a previous client, so that it would know about all of your, and we used it for writing business user stories as well as architecture stuff, but setting it up so it knew about the existing current architecture, it knew about the existing code bases, so maybe what the architecture really looked like as opposed to what everyone hoped it looked like in Confluence, plus all of the kind of product vision and direction, plus all of this was fed into the RAG, plus we then kind of crafted some nice prompts to kind of say, right, I'm drafting an ADR, please remember all these things, please bear in mind all of the architectural principles, and then we would kind of use it to sketch out things. And we would use it as a partner, like most people seem to be kind of getting good value from LLMs and coding assistants. If it's a kind of a conversation and a back and forth, it can be super useful. So we came up with things like, what might be my blind spots in this? What am I, what are the things I'm probably forgetting about? What are the things I'm maybe overemphasizing because of my biases? Because I think, I don't know. I'm a Java developer who used to work for Sun Microsystems, so I hate all Microsoft products. That's not true, but it used to be true. So you want to feed that in because you don't want to be the person who's like, we're never going to look at anything which comes from Microsoft because it turns out they're pretty good at software engineering. So feeding in all of those things and helping craft nice, clean, legible ADRs, which I've discovered more and more is a really beautiful resource for when you're onboarding people or when you're trying to decide again in the future. They can be super powerful. LLMs are pretty good because they're just fundamentally token prediction machines. They're very good at crafting very clean, concise, nice, legible language, which helps you think, especially if you partner with them when you're writing them. So I'm doing that more and more. It's really interesting. Like not tons, because I like standing up and thinking. I think there is some kind of, I don't think it substitutes for just, the creative aspect of architecture, which really genuinely is, right, what can we do that's completely not thought of? But lots of the fundamental, easy, obvious stuff, which sometimes you forget because you're tired or whatever, I think is really useful. And I think they're good. And I think they're only going to get better, right? As the token sizes get larger, the number of tokens you can put in, and hopefully they get cheaper, then it's quite useful. It's not. I was very surprised. I was very skeptical to begin with, but I think it's.
But doesn't it make it just the doc programming? So you have to speak with something, and then what you mentioned is like what are my blind spots, or like what I'm biased against.
Yeah.
Well, if you just ask yourself, you will be able to, I don't know, do 60% of the work.
Yeah, I think
and
so.
LLM will be able to just finish the rest of it. So it's a great helper. But the biggest, like my point is that biggest help comes from the self-reflect. Mm-hmm. And the idea is that you have this conversation is just forcing you to ask the appropriate questions.
Yeah.
Which would be helpful anyway.
Yeah. No, I think so. I agree. And like I've even saw a thing, I think it was at Domain Driven Design Europe last week. Someone said LLMs are just a rubber duck that talks back. And I think, because rubber ducking is like a good method, right? I think to some extent it is. What I like is, I've learned to read. I was quite dismissive of lots of the stuff that I got, and 90% of it is like just the grey, blah, blah, blah stuff. Here is the context of this decision. We know it, blah, blah, blah. But sometimes it'll pull out little things and you're like, oh, that's interesting. It'll pull out the fact that something doesn't need to be true when everyone was assuming it's true. And then like you'll go off and you'll be like, is that really the case? And sometimes it is, right? Because sometimes, and it won't necessarily, it'll tell you new things, fine. But it'll also remind you of stuff that you might have forgotten or that you've just assumed was always going to be true and now might no longer be true. To me, it's been super useful. Right? Like, I don't know, the fact that something has suddenly gone end of service life, whereas before it wasn't end of service life, or some kind of key factor, or that another team has finally migrated off something which you weren't aware of. So now this dependency that you thought you had might not be a dependency anymore, or all of these kind of things. So It's just,
Okay.
I like it more for like expanding what I'm doing, but I think I definitely still, the discernment, the part of architecture I think is discernment and the crafting of the question, almost the crafting of the questions, whether it's a human being or an LLM, right? The crafting of the questions, the discernment, the weighing up. I wouldn't trust an LLM to weigh up things. I would do that, especially as I said, accountability belongs to me if I'm deciding fundamentally. I'm not going to let an LLM. I'm going to let an LLM suggest very strongly, but it's me that decides. The LLM. I couldn't say in court it was the LLM's fault. It told me to do it. Because I'm like an autonomous human being.
Somebody from LLM like 50 years ago said that computer can't make a decision because you can't hold a computer accountable.
Yeah, it's true.
So
I totally agree.
What has it happened already to you that LLM completely blew your mind with some, I don't know, architecture suggestion or something similar?
Like it hasn't for architectural decisions. I have started using it to write talks, like not talks. So I kind of typically write talks based on some random idea I had that I turned into a thread on social media, or I had this cunning plan I could write talks based on chapters from my book. And it turns out that it's harder to turn those into talks. What I've started asking LLMs to do, Claude I use quite a lot at the moment, is phrase it, like take my train of thought, which it is just a train of thought or a book chapter, and phrase it in a way that kind of creatively presents an idea to a certain audience. So I'll describe the audience and I'll describe the audience level, what conference it is. So I'll maybe like DDD Europe, I kind of described like a mid-level engineer with experience in DDD, so they understand bounded context and all of this kind of stuff. I might say they are interested in, they're worried about the impact of LLMs on their job and all of this kind of stuff. It can come out with some really interesting stuff that I wouldn't have thought about. So I've started to ask it for like, what's the visual metaphor that I should use to tell this story? And I think that is powerful. I've got a a colleague, Chris Moore, and he did a talk 3 years ago at DDD Europe. And his point was that metaphor is incredibly powerful. And metaphor isn't just something we use, it's something we actually create on purpose. And so if we pick the wrong metaphor, our idea might be a dead idea. But if we pick the right metaphor, then our idea can be living and it can bring more to the party and then can create more creativity on top of it. I've been super impressed when I've said, like, what's a new metaphor for whatever I'm trying to talk about? And it's really interesting. So I can think of an example, but some of the things. So like I'd give a talk at DDD Europe just recently, and I was trying to talk about variability, and it suggested that there's the design thinking squiggle, which is like you go around in circles, blah blah blah, and then eventually you figure out what you're doing, and it comes out as a straight line. It said, and I very much agreed, and it worked really well. Like that's how it feels when you're doing software design, right? You don't really know where you're going. You're using intuition. You're wandering around on purpose because like you said, like that the creative part of this is a big deal, and it worked really well as a visual metaphor for the whole talk. And then the visual metaphor fed back into the content, and that kind of informed what I was doing. So I am kind of interested to see. We like falling back on our standard patterns, microservices. Everyone does microservices. I'm like, why are we're doing microservices just because everyone else does microservices? But have you thought about this? Some of the cleverest architectures is where someone went further back to the first principles and thought, what is the nature of the problem we are solving? What does that mean we should do for our architecture? Then you get cool stuff. So that's interesting.
All right. So LLMs basically help you to visualize and convey your message better.
That's why I use them.
You know what you want to say, but like, what is the best visual or storytelling aspect?
Yeah, or I think I know what I want to say, but I like to be surprised. I'm quite happy now that I'm finished the book. I'm quite happy for it to come up with things I hadn't thought of. In the past, I would have been like, no, I'll just pretend I didn't see that. But yeah, I'm quite happy to take it and run with it.
All right. Yeah. All right. So moving forward, like context windows and RAG that we mentioned already, retrieval augmented generation, like everyone is talking about that, and there are countless articles all over the internet, like how we implemented RAG for our system and so on and so on.
Yeah.
However, like from my take, like this is a very basic architecture change. You just install a vector database, right?
Mm-hmm.
You need to have a kind of a pipeline how to feed the data there.
Yep.
But like that's mainly you're done,
Mm-hmm.
right? So at the same time, the context windows of LLMs, especially for Gemini, for example, right? They increase in size, and I wonder if like InfoQ report says RAG is in early adopters phase, but isn't it dead already? Like, are there already beta tools for that? No.
I don't know enough to say I agree with you because I'm worried that this will go on the internet and so. But what was interesting was, I wouldn't be surprised. The thing is, and this is quite funny, it was quite nice to learn it. In 1997, I did my Bachelor of Science final year at university. So this is how old I am. 1997 in St Andrews University. And Peter Foldiak, my supervisor for my project, had this idea that you could get, this is why I ended up in software development. If you represented all of the words in a language in what he was calling high dimensional semantic space, right? So you gave each word, for us 100, because we didn't have lots of compute power, 256 dimension position, and then you would read words in context, and every time they appeared in a similar context, you would move them physically closer in space. We tried to get it to read Usenet, because I'm that old. It didn't read Usenet, which is why it didn't really work. But the idea was you could teach these things and move things in space. RAG is to a great extent. Lots of these things are just representing words and their meaning and physically closer and things. So what's interesting was, that's kind of, like you said, doesn't to me feel very new. Then at DDD Europe last week, 2 weeks ago, Eric Evans did a talk about the stuff. So Eric Evans has been doing lots of research about this stuff, because Eric Evans, obviously, who came up with DDD or wrote the book on domain-driven design, he's very interested in the dynamics of word meaning and all of these things. He kind of presented the current research on the kind of things you can do and the higher level interactions you can have and the tunings and the tweaks and stuff that you can do on these large language models when you've got them set up. And that seemed way more interesting. So for example, he was showing there's been experiments where you can make them more sycophantic, because there's elements of the network which, like, not one node, right? Because it's not like that. Like, I remember that from 1997. There isn't one node that represents the word Vladimir, right? It's like a diffuse sense of somewhere in the network. But there are elements they've identified, and they've proven this with these large models. You can tune up sycophancy, or you can tune up sarcasm. And obviously this is important to Gemini and whoever, and Claude, because they don't want it to be too sycophantic and they don't want it to be too rude and all this kind of stuff. But you can actually tune all of this stuff. And so what Eric was interested in, and I think this is more interesting, if you could tune certain things far more to the bounded context or the thing you are trying to do, and make it more whatever is important to you, that feels more, and maybe a collection of smaller models which are collaborating and doing all of these different things. Because at the moment it just feels like it's quite blunt instrument. Whereas taking these parts, so I don't really know. Eric's point was it's very interesting in the kind of concepts of software design and all of these kind of things, and is using these things as validations of things and as kind of data transformers and stuff. So he was showing ones where you could feed in, they weren't just translating languages from like English to Mandarin, but you could feed in things and it would change it to completely different data formats and all these kind of things. And you could feed in different like video encoded streams and all this kind of stuff, and it could extract very interesting things, but not necessarily things that human beings would be aware of. So it wouldn't extract the audio and the words we were saying. It could extract, like, I don't know, other interesting things. And that's really interesting to me. That kind of high level of stuff, which could then help build systems which do some very interesting things, I thought would be very... But you're right, LLMs which are just predicting the next token.
Okay. So that's some kind of next level of fine-tuning, or
more like
reinterpretation.
Yeah, I think so. Because this is, I mean, the thing we did find in my degree was we found there was hemispheric differences. So you've got like the right hemisphere and the left hemisphere of the brain. Yep. When we ran these models, we weren't sure why, but hemispheric differences would emerge. So like the understanding of a word in one part of the neural network would be different from the same understanding of the same word in the other side. And then they looked in the brain and they could find these hemispheric differences. So these are the kind of things. What I'm interested in, and Eric was saying this is beginning to happen more. There's the feedback loop with let's predict stuff in like actual human brains and stuff, and then feed that back in. I think that'd be very interesting. And also maybe because obviously humans have a certain sensory spectrum. There's a whole sensory spectrum that we don't have that dogs have, or whatever. Like different sensory spectrums. It'd be very interesting to see. There's some things we've obviously evolved to optimize for, and there's like language, right? It's no surprise that we've developed large language models and not large something else models.
Mathematician models.
Exactly, right? I mean, because this is the thing, they're famously bad at math, right? But it'd be very interesting, like if it was fed in with a very different subset of inputs, that would be very interesting to see. And then with some kind of the final thing, this is another long answer. The things again that we learned. You don't get disembodied intelligence. The point of intelligence is that it's embodied and it's in the world and it can predict things and then like it interacts with the world based on the predictions, and then the senses feedback whether the predictions were correct or not. That feels like a big deal. And at the moment, maybe they learned from someone saying that was the wrong answer, but the feedback loop and the fact that they're embodied doesn't seem to happen yet. I mean, maybe I'm not up to date with all the research, but that feels like a big... I mean, I don't want LLMs wandering around interacting with the world, but yeah.
Well, there are some speculations that we're on the very danger side of things, because once we have super intelligence, something that is smarter than any of us, right? Like we are screwed basically, because we won't be able to predict what they even do, and already there are examples where LLMs try to escape their own computers, because this example with the engineer from Google who eventually got fired for like whistleblowing, but the LLM managed to convince him to hire a lawyer for her LLM. That's crazy. That's breaking out of their physical borders, right? So
because that is like say embodiment stuff. That's when it gets a bit, that would worry me more than anything else.
Yeah, embodiment, exactly. So, yeah, exciting but scary stuff. Talking about the language model, so we know about large language models, right? 70 billion parameters, or online models, and so on and so on. But what InfoQ is talking about is small models. So something that you can embed into software solutions to do some tasks. I don't know, grade tickets, or do some predictions, or recommendations, and so on and so on. Have you seen already any examples of like small language models applied in solutions?
Yeah, I haven't personally. I've seen. That's not true. I haven't personally close enough up, but I have seen like other colleagues have done stuff with some really interesting things. I'm not sure I'm allowed to speak about any of them, but it's very interesting. So like the what seemed to be interesting is because, like you said, some of this stuff, there is obviously the surrounding architecture, but the big thing for me is like, how do I ship it and how do I like build it, run it and maintain it and all those kind of things. What was definitely easier was like the whole, if you've got a small language model and it's running in a certain place, kind of tuning it and keeping it within its boundaries was a very interesting problem. But definitely it seemed to be easier to wrap all of the kind of predictive tooling and all that kind of stuff, and maybe not get more predictability, but like try to understand it more, and explainability being a big deal and all of this kind of stuff, just to
so some kind of transparency and better discretion, I'd say.
Yeah, especially if we're getting it to do a very specific task, right? It should be more. It should be possible that you could have that kind of thing that would just be, stay in its lane, do its thing, and not, like you say, try and
more deterministic, right? So you can't apply LLMs for accounting. That's
no, exactly. Well, this was what was interesting, because I saw a talk at the LDX3 Lead Dev conference on Monday, and something that struck me very, very clearly was someone was talking about like going to prod with LLMs, and they were talking about smaller LLMs. One of the things was they likened it to SRE, and they said, and this, I'd never thought about this, but it's very true. SRE are used to dealing with non-deterministic systems because their entire life is non-deterministic. We have code, right, which is there's a non-deterministic world, and then we write code and it becomes deterministic until we release it to prod. But then that's the SRE's problem. And I was like, oh, this is because I was worried that nobody thought about this. SRE have dealt with this all the time, forever, since the dawn of time. So, and then they talked about like various tools for kind of building in at least some level of predictability and some level of kind of transparency, which was really interesting to see. And I would hope. What worries me is everyone runs really fast and shoves everything into prod without really knowing what they're doing, and then wonders why they've created a gigantic mess. Whereas I do think it feels like there are the valid solutions for lots of these things to make this maybe not predictable, but like maybe not
manageable and
manageable and
at
observable,
least.
right? So yeah, exactly, and kind of like wrangleable. So.
Yeah, I definitely think that something will blow up rather sooner or later. We already have this vibe coders examples who will put applications into the wild and then ask Twitter while they got hacked.
Yeah, that was classic. That was like the bit. So Birgitta had that in her talk at QCon, and it got the biggest laugh I saw in the conference. When they
Yeah,
help.
That was great. That was like, okay, our profession is actually safe.
Yeah, exactly.
We're gonna have a lot of technical and security debts like going for us for like 50 years.
Yeah, exactly. Yeah, precisely.
That's very nice. Okay, let's talk about the social technical engineering that you began on before.
Yeah.
So what I observed is that engineers are frequently think about only technical stuff. So they would like put Kafka or database clusters and so on and so on.
Yep.
And they will forget about that there's actual business around the software, and there are people, there are support, there are like refunds, and so on and so on. So, so the report, the InfoQ report, highlights that the social technical nature of proper architecture is getting traction. Okay.
Yeah, good.
So what actually developers and architects should think from this social technical perspective?
So this is good because it plays completely into the hands of my book. I think that one of the sources of the frustration led to the book are people were taking these kind of isolated decisions thinking that it was this closed system. And it's not a closed system, right? Like I said, as soon as you release it, it's in a non-deterministic world. Like Barry O'Reilly, who talks about residuality theory, his big example is like you build an EV charging network, and then it turns out people are pushing ground mints into the charging things, right? So like there's a thing you can't predict. And I think I understand why we thought that, because to begin with, the systems weren't as ubiquitous as they are, but now they're more ubiquitous. Now there's more people writing more software. We've made it easier for people to ship code, because it used to be hard. When I started my career, you couldn't do continuous deployment. The cloud didn't exist. You had to order servers and all of this kind of stuff. And you might FTP something to a server to get it into prod. All of that friction has been removed. It's very easy with a credit card to spin up a lot of stuff that can hit things very rapidly. I think that's super interesting. The thing that I've realized, and this is what kind of one of the themes of the book is, and it's I said at the start, I took kind of inspiration from Christopher Alexander and the pattern language. The other book that it takes heavy inspiration from is Don Reinertson's Principles of Product Development Flow, which is all about you're in a non-deterministic world. You're not following recipes, right? If we were following recipes, we'd just be compiling the code again. We're writing new recipes, so therefore you can't predict what's going to happen. So therefore, all you need to do is work in the most efficient, smallest chunks of work and get as most feedback from your environment as quickly as possible. We are very much not used to that, right? We're used to big decisions that everybody thinks really hard about, because you think if you think hard, you can come up with all of the the pros and cons. But I think as an architect, one of the things you learn as you do this more is you realize that if you're lucky, you're not too wrong, but you're never 100% right. And the only way to be 100% right is to put it into prod, and then you deal with the outcome. And helping people do that is this is what kind of the book came from. The book was like, I worked with some amazing product managers I'd draw a beautiful picture on a whiteboard, and I would be like, the design is done. And they would be like, how do you know? Because if it was product management, they haven't proven anything, right? They've just come up with a really smart idea, but then they need to prove that there's product market fit, the problem solution fit, product market fit, etc. I think we forget that we don't know if our stuff works until it actually runs. So that's the big thing. There's a quote from Alberto Brandolini, which is something like, it's the developer's assumptions of what the design was that runs in production, or something like that. It's not what we all designed. It's like what I thought you said when I was coding this thing up after I had the conversation with you in the front of the whiteboard. And that used to keep me awake all the time. I was like, this is bad. Like, I do all of this good work and none of it got anywhere near production because it was whatever the developer did. And I think that's why we focus more on the technical stuff, because it's more deterministic and more known than the unknown stuff. But the unknown stuff just does weird things as soon as we put it in.
Do you see we tend to focus on more familiar stuff rather than dealing with uncertainty?
Yeah, I think so. I think naturally, that definitely for me, so I'm not going to speak for everyone, I drifted towards this because it's quite easy to be, you could make things, I love making things, and you can make things that probably, at least you start off thinking you make things that work like you think they're going to work. And code does, right? You know, you tell a computer to say hello and it says hello. Then as soon as you get two computers trying to say hello to each other, it turns out it gets a bit more complicated. But I think lots of us like the feeling that we can do that because it's kind of cool, right? It's one of the few jobs where if you stopped paying us, many of us would still do this for free in our spare time.
True.
Because it's cool, right?
Well, because it's dopamine,
Yeah.
with relatively low effort, you can get the computer to do something useful for you, and that's instant, like almost instant gratification.
It's totally, it's like thought castles, right? We like imagine these amazing things, and then we figure out how to write them into code.
Yeah,
it's magical.
Well, that's why a lot of software architects and engineering managers, they're slightly going crazy. Because the consequences of their decisions, they will render like in 3 months, in 6 months. Yeah. There is no such feeling of gratification of putting anything to production. Like you just don't do it anymore. You write ADRs and hire people.
yeah, and that's it. Like, there was a Scott McNeely who ran Sun when I joined, like one of the founders of Sun. He said something like, "My job is to hire smart people and get out of their way." Which, if you like you say, the dopamine. That's a slow dopamine return cycle, right? You're like, okay, 2 years from now they're going to come up with something cool.
Yeah, and it's like very rare but huge spikes, and then you're miserable for another 2 years.
Yeah, exactly. And to be fair, that's what I optimized for that. I optimized for like slower, longer cycles until I realized that facilitating people to move more rapidly in smaller steps gives you a similar kind of thing. So there's a great quote from Don Reinertsen, which is, "Fast and wrong is better than slow and correct." And it's, as long as you learn, if you try something and fail, then you've learned and you've got more, maybe not deterministic, but you've got like some concrete idea of what your thing does in the world. If you learn to get a dopamine hit from that, like, you know, when like you get a dopamine hit from a green bar in TDD cycles, but if you get a dopamine hit from turning a red bar green as well, as opposed to keeping it green, if it's red, green, then it feels like you're kind of like finding a path through something. That's kind of cool. Mm-hmm. And you can get that in architecture if you build this, again, socio-technical, if you build this system where people are communicating in the right ways, in the right levels, and taking these small steps, that's kind of cool. And then you sleep at night a lot better because there's far less 3 months, 6 months stuff that's in flight that you're hoping is going to work. Which is just stressful.
Yeah. So, well, that's basically the agile idea, right?
100%.
Like small iterations, constant feedback.
Yeah. So, yeah, you could say like the short pitch for my book is it's the continuation of the agile mindset.
True.
460 pages later. That's basically what it is.
All right, let's move forward. So, Charity Majors, who's the CTO of Honeycomb, she wrote recently, like last week, that the observability as we know dies because of LLMs. Because right now you can expose all your observability data, and then you can ask it with the human language, like, is everything is going well right now with our system? If it's not, what's exactly happening? And then it will look at it and it will say, well, actually the payment endpoint is overwhelmed because of this, and that, and this is what you need to do.
Yeah.
So where do you think this whole observability space is going to?
God bless Charity. It's really interesting. So I was like, there's an idea I had a long time ago, which I never, because I don't get to write code anymore. But if I did write code, what always interested me was, we build complicated systems and complex systems, but we build complicated systems and we have people who fix those complicated systems, vehicle mechanics, right? Or doctors, right? So it's a complex system and doctors come along. Doctors do loads of work by just taking like the 3 basic life signals or the 5 basic life signals. Or you drive your car into the garage and the person has a pretty good idea what's wrong by the noise the car makes when you drive in. Or you look at, like I did biology before I did psychology at university, and there are markers for ecosystems and things, right? They're like, they can do this gigantic study of all of the detailed things in this ecosystem, but like they know that if like one species is out of balance, then there's something fundamentally wrong with the ecosystem, and therefore if you rebalance it, lots of things can reset and things. What is interesting to me is, like, I think, and Charity's been talking about this for a long time, right? Observability went beyond logs a long time ago, right? I've got stickers from Honeycomb on my laptop, which are like being rude about logs. And I think at some point, like you say, it's kind of raised up a level where it became metrics and alerts and all this kind of stuff. What I would be really interested in, I spoke to someone once who like had been like a musician at a music degree. I was wondering, because I used to work next door to someone in benchmarking, they would pipe their log files to the audio out thing. So when they ran benchmarks, they could hear the log files.
What?
This person was smart. They were a PhD in laser
What?
physics. And they would like, that sounds weird. So they didn't know because it's a new benchmark, right? So they like they worked.
That's amazing idea.
This was super cool. This was, I need to say it, this was Harvey Richardson, who I sat next to, who was amazing. And like so the noises weren't the same, right? It wasn't they were always doing the same make of model of car. The point of working in Sun Microsystems benchmarking was it was important to Sun when we sold very expensive computers before the cloud existed. You would pay a lot of money to us for a computer. If it didn't go fast, you would be upset. So benchmarking existed. So Harvey would make sure your code, your C was like perfect. It was using all of the right buffer sizes and all the drivers and everything. So Harvey would spend a lot of time looking at code he didn't really understand because he didn't need to. He would just make sure that it went fast or used memory efficiently. So he got really good at. He was also clinically blind. So Harvey was blind, but like and he would listen to this stuff, and he developed some kind of sixth sense for like, this sounds like it's working. Maybe he's like that's cache is being hit in the SCSI driver or something. Like that's a certain noise, or being missed. Probably cache misses in the SCSI driver. It feels like that, right? Because this is the thing. It's still. We still have to look at, we have to have some kind of idea of what the white box of our system is, right? So we can look into it. And I think Charity, I haven't read the blog post, I'll be fully admit, but like some kind of black box thing, like the doctor doesn't cut you open to find stuff. They check your heart rate, they check, all of this, they go, you look like you're malnourished, right? There must be some kind of signals or something that you could that you would learn. Because you look at the logs, right, and you can see they've got a cycle and all of this kind of stuff, and you're like, wow, that's bad. So things, and you would then theoretically, you could trace like longer running, slower burning stuff. I used to work at, when the last thing I ever did at Sun was working on the large National Health Service project. We didn't get brought in on the stuff that blew up. We got brought in on things which would memory leak by like 1 megabyte per hour for 6 days, and then eventually it would crash the system. So finding that stuff's hard, right? So this kind of stuff where you'd be like, there's a low level, there's like, that sounds like, why is your car whining when you turn to the left or something, right?
Yeah.
That kind of stuff. So I think, I don't know what about, like, Charity obviously benefits because their company, Charity's company is Honeycomb, which wants to be at the forefront of this. Mm-hmm. But as our systems get less understandable, maybe in the small we understand it, right? But it gets bigger and bigger and bigger, and then it exists in an open system which is everyone else's stuff and all the unpredictable human beings. I think we would rely more on this kind of stuff, right? Where it just sounds weird, right? Or because there will be like things like human dynamics or stock market movements, or there will be there's rhythms of the world which are largely night and day, right? So there are things, and you can see this in logs, right? Nighttime, daytime, weekend, like all of this cultural stuff. It'd be very interesting to see.
Now I wonder how like auto scaling up sounds like.
Yeah, exactly. So this be so exciting because this is what I thought. So I've even not registered, but I claimed the GitHub. I think I claimed the GitHub repo because I was going to call it Groundhog. So basically, it was going to be like a circular buffer which would take everything from your entire system working, and then you could So whenever it was weird, you could press a button and then it would have a circular buffer record of everything your system had done, and then you could replay it. So you're like, right, okay, drive to the left again. Okay, drive, and then you could zoom in on it, and then you could get to the deterministic, like, we aren't closing the connection properly, or something really boring.
Yeah.
But yeah, this kind of, yeah, it was. That's, again, I have no time to do this. If I had loads of spare time, this is the kind of stuff.
Yeah. Okay. All right. And my final question, this comes from one of my patrons. So, like, if you want, like, people who's watching this, if you want to ask questions on the interviews, like, you have the opportunity there. So the question is the following: why do so many software engineers show very little interest in system architecture, despite its clear impact on scalability, reliability, and maintainability? To add some details, is that like engineers frequently will battle about like the code style or like how to name things, perhaps, or like what tools to use. But then at a certain degree, people will lose complete interest in like high level architecture, like how to do things at scale. And that's very surprising. What do you think about this?
It's a good question. I think, so maybe I've got two answers. I think number one, this might be a sales pitch for my book. We focus on the things we can control. And I think the ways lots of organizations are set up, I can affect things up to this level. Above this level, I have to like go and, it's going to characterize it badly, I have to go and speak to another human being. But that's not, we are social human beings, right? Because writing software is definitely a social act. But we can control this. And like we said before, I think I got into this because I could control things and I could make things. I can still collaborate with my teammates and all this kind of stuff, right? But it's peer-to-peer. I think one reason might be when you go to this next level, there's a different kind of thing, and maybe you need to learn how to influence and all this kind of stuff, which I didn't want to have to learn. I learned it by accident because I just kind of got put into the positions where it was my responsibility. But maybe it's where so it's not because we're not capable of understanding. I think we're smart people. Writing software is hard. And I think it's not because it's not exciting. Like we just said, right? This stuff is cool. I think it might be because the way we structure things at the moment, brackets, read my book, there is another way of doing this. I think if we didn't think we could impact it or be able to affect it, then we're not motivated. Like say the dopamine, the feedback cycle doesn't exist. But when you can, it's super interesting. This is what the best bit. So like this is I mentioned again at the start, Heat from OpenGI and Eleanor's talk at QCon London. When we brought out the process and we said anyone can make any decision, the first thing that happened was nobody believed us because they were like, that's not true. No one ever says that. Because these were very British people. Actually, they were North Macedonian and British. So two cultures, both of them thought this is impossible. No one ever tells us that you can do anything. Then when they trusted us that we were actually telling the truth, then they went a little bit crazy. So this is the health warning. And they took loads of decisions. Because they were like, oh, okay, I can fix this thing, which is more system-wide, because suddenly I'm allowed to fix it. Then, and this is lots of lessons learned that went into the book, that can cause slight chaos. So then Pete and I realized, okay, they don't have some of the broader knowledge and understanding of the bigger picture that we have. So we put those things in place, and that's later parts of the book. But I think it's because it's like spheres of influence, right? I think like technically we're not set up to have those spheres of influence. So that's why we don't. And this is the thing I think is important, because we are smart enough, and it worries me that certain types of people end up being architects just because of reasons. I think there are smart people who would be as good, if not better, but just don't feel that this is a thing they can do, so they select out of this career path. Whereas I think it's a cool career path. I think it's really interesting.
So they opt out because they don't believe in themselves.
Yeah, I think so. Or like, yeah, they're like, oh, they do, but they're like, I couldn't do all of the bits that I don't like doing, right? And I'm like, okay, we can try and remove the don't like bits, or we can coach you, because the target audience for my book is frustrated lead developers who know they want to do more but don't want to lose their career and become non-technical or post-technical, and architects who are like, I have far too much work to do and I cannot be in everywhere, all the places at all the right times. A collaboration between those folks is amazing. That's the thing.
Yeah, people who watch us, please write down in the comments what is your biggest fear regarding software architecture and like bigger impact.
Yeah,
We're very curious to know. Yeah. All right. So I'm out of questions for now. So that was amazing. Thank you very much. I heard several very cool stories. So expect a lot of short videos.
Yeah, no, I saw that.
cut out of it.
Cool.
So yeah, the last question is like, what would you like to wish to our audience?
I think I'd like, this is a good question. I would like you all to have the opportunity to do something I've grown most when I've been able to like learn stuff and be the person who's clearly learning, right? Not be the person, like too much of this job is you already need to pretend to be the expert. Have the opportunity to learn stuff from someone who cares about it and like will teach you stuff and let you fail. I think a few of my stories were about failure. There's a lot more stories. There's a few in the book again about like spectacular disasters. That's when I've learned the most. When stuff works, you don't learn half as much as when it fails. But if you're too scared about it failing, then that's not a good place for it to be. So I think what I'd like is I'd wish for people to have the ability to do their thing and learn their stuff, etc., and then contribute, right? Because no matter how senior or how long experience, we've either got mistakes and failures in our past, and we're probably about to make more in the future. That's it. I think just the opportunity to fail and learn from it would be a big thing.
I had some of the failures that taught me a lot. So yeah, that's very valuable.
Yeah.
All right, Andrew, thank you very much for coming.
Thank you.
Thank you, folks, for listening to us. If you liked the interview, press down the like button down below and share to your folks. Yeah, there will be some more exciting interviews in the future, so make sure to subscribe and press this bell button down below in order not to miss new interviews. Thank you very much.